Hi, Viper Chemistry students. Hey, in section 2 of Unit 9 slideshow is equilibrium expressions, or chemical equilibrium is what's known as. We'll show you how to actually solve for what is known as the equilibrium constant. So let's take a look. Now, in these types of problems, really what we're looking for, or what we're referring to here, are reactions that are ongoing both ways. They're reversible, so they go one way and then they react back the other way. So uh, we have reactants that are forming products, and then products that are breaking down to form reactants, and so it's both ways. And so that's why in these you'll see a double arrow. As you can see here, there's two arrows there. Okay, so that tells us it's a reversible reaction. Now, this diagram also kind of refers to that idea. So if we just use letters here, A plus B goes to C plus D, the product C plus D, then C plus D goes the other way to A plus B. So there's like this interaction constantly going on. Now, what really becomes important here is that you can use an equation to get an idea for, like, are there more products, are there more reactants, and so you get what's called the equilibrium constant, and there's a way to solve for that. So we'll look at the formula for that, and it allows chemists, it's a helpful tool for chemists to kind of think about like the concentration of either the reactants or the products. And so let's take a look at what that means. So here it is. The breakdown of the formula looks like this. It looks kind of intimidating at first, really, but these, like N here in front of the A, is really the coefficient after a balanced equation. And then when you solve for the equilibrium constant here, you basically put the reactants on top, or excuse me, the products on top, and their coefficient values as exponents. So products are on top, reactants on bottom in terms of a ratio. So you're forming a ratio. You're using the coefficients in the balanced equation here, N, M, X, and Y, if we're using letters to represent that, become the exponents in the equation. Now, important to know is that pure liquids, like if it just H2O, we'd throw that out. If it was just solid, a solid, that is not included in this equation. It is only entities that are considered solutions or concentrations where there would be a concentration, something that would have a concentration. Okay, so we'll do a few problems this week, and won't get too deep into it, but that's the idea. Now, there is some examples here, so I'd want you to really look these over. They're going to be in your notes, so be sure when you use your slideshow and you do your notes, you kind of pay attention. If you kind of follow the way the slideshow, shows how to solve these, I think you'll be okay. And then there'll be some problems where you actually plug some numbers in. Now, a note on that. You have to use molarities here. Molarity is moles per volume. And so when you do these types of problems, it has to be in the molarity unit. Okay? So be sure that you solve for that. Moving on here. There are some video clips that you're going to see occasionally. It might be worth looking at. Now, how do we interpret the number? So when we do solve for the equilibrium constant, if you get a number greater than 1, that means that the concentration of the products tend to be greater, have a higher value. So it favors more particles over on the product side. If you get a number less than 1, and remember that this is based on a ratio. If you get a number less than 1, then really the particles are favoring the reactant side. There's more particles to work with in the reaction. Okay, so that's kind of a breakdown of this chemical equilibrium idea and the chemical or the equilibrium constant. So good luck. Do your notes. We'll solve a few problems this week, and then we'll go from there. All right, best of luck, and thank you for watching.